Good morning, my dear students. My name is Andhani Sharma, working as physics lecturer in one of the reputed institution in Hyderabad. Today, we are going to know some of the important questions for IP point of view, means Board of Intermediate for both the states, Telangana and AP state. Okay, you please subscribe my channel. I am going to give you more and more updates in intermediate also. Okay. Now about an important question, that is why pulling process of a lawn roller is easier than pushing. Okay. Now we are going to know one important 4 marks question, that is why pulling a lawn roller is an easier process than pushing. Very simple. Okay. So if you know some important points under this, easily you can answer this question without any confusion. Okay. So I hope all of you know about lawn roller. So you know lawn roller we are using to level the ground, right? So let us consider one lawn roller, okay, of mass m. Okay. So now you apply some force on this outwards, that is called pulling. If you apply some force inwards, that is called pushing. Okay. Now let us suppose F force is applied on the roller inwards, called pulling. Okay. So F force you are applying on the roller outwards. Okay, so then you know this vector quantity F resolved into 2 components. Okay, so let us consider this is a lawn roller, okay, of mass m. On this with horizontal F force is applied inwards, called pulling. Then you know this force resolved into 2 components. Okay, F cos theta. Okay, F sin theta. Okay, F cos theta, F sin theta. So you know whenever a body is kept on the ground, always its weight is acting downwards. No? So always weight downwards, normal reaction upwards. That is, you know, according to Newton's third law, for every action there will be equal and opposite reaction. So you know when certain force is acting downwards now, its weight acting down now, so thereby the reactive force, normal reaction, acts upwards. So if you notice this F sin theta is added upwards, that is when you pull the lawn roller at an angle theta with horizontal. That means it's very clear that F sin theta is added towards normal reaction. So this is a point you need to remember to derive this derivation. So you know weight always downwards, normal reaction upwards, no change in that whether you pull or push, right? But whenever you apply force outwards, say pulling force applied on the roller, then this F sin theta is added towards normal reaction. So if you remember this, it is easy to derive the derivation. You see the roller is moving only horizontally. No up and down movement. No up and down movement. Only it is moving horizontally. That means it's very clear that upward forces are balanced by downward forces. No? So mg, right? mg is equal to F sin theta plus normal reaction. Okay, mg downward force equal to upward force now. So mg equal to F sin theta plus n. Right? Then you know normal reaction, right, is equal to, okay, mg minus F sin theta. Okay, mg minus F sin theta. Okay, mg minus F sin theta. Okay, so you know frictional force is always equal to, remember, mu n. Anywhere frictional force equal to mu n. Okay, so you know mu as it is, mu means you know coefficient of friction, right, between the ground and the body. No, so there will be some friction. The roller is moving on the ground now, so you know there is some friction between them. So that coefficient of friction taken as mu. Okay, into n, that is you know mg minus F sin theta. Okay, so this is the frictional force when you apply F force outwards, nothing but you can say pulling force. Okay, now we are going to apply F force on the roller. Okay, F force we are going to apply on the roller. It is all about pulling, no? In case of pulling. Okay, now about pushing. That means you know the same roller force is applied on the roller inwards, no? Okay, so you know both the cases weight always acts downwards, normal reaction acts upwards, no change in that. So now F force is applied on the roller which makes an angle theta, okay, with horizontal. Now you are applying F force on the roller. Okay, it is nothing but you can say pushing process. Okay, so in this case also you know F resolved into two components, no? F cos theta, okay, F sin theta. So if you notice this F sin theta is added towards weight, no, instead of normal reaction. So this is very, very important. In case of pulling force, F sin theta is added towards normal reaction. Okay, so in case of pushing force, you know, F sin theta is added towards weight. So you know the roller is not moving up and down, no, it's only moving horizontally. That means upward forces are balanced by downward forces, no? So that is why, you know, N is equal to, okay, F sin theta plus mg, no? Therefore you know frictional force is equal to mu n na, means F sin theta plus mg, no, into coefficient of friction mu. So this is the frictional force in the second case, this is the frictional force in the first case. Okay, so now you know work done is always force into displacement na, force into displacement. So in this case you know you require more friction to overcome. Over here less friction, to overcome. So whenever friction is more, work will become difficult because you need to overcome that now. So in this case, less frictional force. That means work will become easy. So in this case, friction is more, so work is difficult. That means it's very clear that pulling a lawn roller is an easier process than pushing. Okay? Pulling a lawn roller is an easier process than pushing. Okay? Now about another important question, that is state and prove parallelogram law of vectors. Okay? Very important question, IB point of view. Now we are going to prove parallelogram law. So mainly this parallelogram law is useful to find two vectors, addition of two vectors. That is when they are co-initial. Co-initial means, remember, the initial point must be same. Say there are two vectors like this, having same initial point, means starting from same point, inclined at an angle theta. So in order to know the addition of two vectors when they are having same initial point. Okay. So according to parallelogram law, whenever two vectors are taken as adjacent sides, okay, as adjacent sides of a parallelogram, diagonal, its diagonal gives their resultant. That is, whenever two vectors are taken, you see this catapult, you take one object, okay, apply some force in this way. So both the forces are acting at one point, but you see it is moving in diagonal direction. Means it is very clear that whenever two forces are inclined at an angle theta, okay, applied on a body, the resultant nothing but their diagonal. You see about a flying bird, when the bird stretches its wings down now, it will be moving in diagonal direction. Or you see leaving an arrow from a bow is also an application of parallelogram law. Okay, so whenever two vectors are inclined at an angle theta, diagonal gives their resultant. Okay, that is parallelogram law. So let us consider two vectors, say OA, OB, of magnitudes, say P, Q. So you have taken two vectors, OA bar, OB bar. Magnitude of OA, P. Magnitude means length. OB, Q. Okay, so this represents the diagonal, say OC. So whenever you complete the parallelogram now, this diagonal represents the resultant. So OC represents the resultant, diagonal. No? Say its magnitude is R, which we supposed to find now. Okay, how? Very simple. So you extend this forward and you drop one perpendicular. So if these two are inclined at angle theta, this angle is also theta now, parallel. So if this magnitude is Q, this is also Q. Okay, because it is a parallelogram. So what is the statement of parallelogram? That is, whenever two vectors are inclined at an angle theta, diagonal gives their resultant. No? So OC gives their resultant. So this COD is forming a right angle triangle. So in any right angle triangle, square of hypotenuse, no? OC square equal to, you can take OD square plus CD square. Na? So OD, nothing but OA plus AD, right? Whole square plus CD square gives OC square. No? So this OA plus AD you can expand in the form of A plus B whole square. No? So A square plus B square plus 2AB, no? Plus CD square. So here OA length is P now. Okay. OB Q are known to us, right? Now you want to know this AD and CD. So you have to consider this triangle. Okay, triangle CAD. Okay, triangle CAD. So whenever you want adjacent, we take cos theta now. Cos theta is equal to adjacent by hypotenuse. No? So AD by AC. Okay. So AC is same as OB na Q. Means cos theta is equal to AD by Q. Or else you can also take it as AD equal to Q cos theta. No? Next. CD. Opposite na? In this triangle it is opposite. So whenever you require opposite, you take always sin theta. Na? So sin theta is equal to opposite by hypotenuse. Nothing but you can say CD by AC. Okay? So CD, this is Q now. So CD is equal to Q sin theta. Okay, so now substitute in this equation. OC taken as R na, so R square, right, is equal to OA square, nothing but P square plus AD square, no, AD nothing but Q cos theta na, so Q square cos square theta plus 2 OA AD na, so 2 into P into Q cos theta, AD taken as Q cos theta na, plus CD square, CD is Q sin theta na, so Q square sin square theta. Okay, so in these two Q square is common, right? So you can take P square plus Q square of 1. Why? Because trigonometric identity. Sin square theta plus cos square theta is always equal to 1. Right? Plus 2PQ cos theta. No? That is R square. Right? You want to find R now? So root over P square plus Q square plus 2PQ cos theta. Means whenever two vectors are inclined at an angle theta, so the magnitude of the resultant is given by root over P square plus Q square plus 2PQ cos theta, where theta is angle between the two vectors. So this is only magnitude. No? You need to find direction also now. Now let us assume that the resultant, say OC, is making an angle alpha with OA. Okay. So you consider again this triangle COD. Okay? COD. Tan alpha. You know, tan alpha from this is opposite by adjacent now, means CD by OD. CD by OD. So CD by OD taken as OA plus AD now. So already we know CD, AD and OA. Substitute. So tan alpha is equal to, okay, CD Q sin theta na, by P OA is P na, plus AD. You know, AD is Q cos theta na. So this is about tan alpha. You want to know only direction, means alpha. So this tan, if you are taking to other side now, it will become inverse. Okay? So tan inverse. Okay, tan inverse Q sin theta by P plus Q cos theta gives direction. Okay? This is magnitude. This one, direction. Okay? Very simple. Thank you for watching this video. Please subscribe my channel. I am going to give you more and more updates in intermediate important questions to you. Okay? Thank you.